Hello, this is Tommy, and I'm going to go over my assessment for heaps and hashing. So, the first question is asking us to remove the minimum from this min heap right here. And so the first step is to swap the 1 and the 2, because the 2 is the last element in the array representation of this heap. So removing it would still preserve the completeness invariant. So we're going to put 2 at the very top, um, and the rest of the heap will stay as it was, except the 1, which is the value we want to remove, will be in its place. And now we can get rid of the 1, um, and then find a place to sync the 2. So obviously 2 is greater than 1. So we will 2 is less than 5, but 2 is greater than 1. So we will sync it down by 1. And here we don't sync it further because 2 is greater than 6, so 2 is in its 2 is where it should be, and that is the final stage after removing the minimum. The next question is adding 0. So when we add to the heap, we again add to the very last element in the array representation, which would be the furthest right in the tree representation here. So it will first be here, but then to fix the invariant, we would have to I think swim it up. So 0 is greater than both 1 and 2. So this would be, it would first swap with 2. So this would be 1, 0, 2, and then it would swap with 1. So it will be 0, 1, 2. And now the array, the heap would after you swim the 0 node up, it would turn into the correct configuration. And yeah, that is binary heaps, and the next is hash tables. So for the hash table, it's helpful to see what the code is going to construct in memory. So first it creates a map of hash. It creates a array of length 4, which is our buckets, and it never resizes. So this will always be of index of 0 to 3. We will create 2 objects A, B, with Lily and Ahmed. And first we add A mapped to the integer 1. So it will be this, and the place where the bucket at which we inserted would be the hash would correspond to the hash code mod 4. So currently it would be A would be Lily, hash would be 5 because that's the length, and the same would be true for Ahmed. So 5 mod 4 is 1, so this would fall into the bucket index 1. And now we're going to put B mapped to 2 into this hash map. And because this is also going to fall into the same bucket, because 5 mod 4 is 1, and we're not going to replace anything because B is not equal to 1. This will just append to what is already there. Now we're going to add A's name to itself, so we would have Lily, and hash code would turn into 10. So now adding this, the modified version of A, they're all the same, they're all the same object, but now adding A now would give us a hash code of 10, which would be the second bucket. The bucket of index 2, which would be here. Now the next line is putting B mapped to 4 But B's hash code is still 5, so we're still going to be looking into the bucket of index 1, but we see that something is already here. We already have the same husky object here. So in a map, we would replace the the old value with a new one. And now we're going to do the same thing with increasing the name for Ahmed. And adding the object corresponding to Ahmed map to 5 into the map. So this would now have a hash code of 2. I mean, hash code of 10, which would correspond to 2, and go here. Okay, so this is kind of the final state of the map. And this is going to help us answer the 4 questions. So map.size, why does it return 4? Well, as we can see here, it never resizes. It starts out with four buckets, and it ends with 4 buckets. So all these operations does not change the size. So question 2 is why does new husky getting the value of a husky object literally return null? Well, in this map, we've changed all the objects, A objects from name Lily to 2 lilies. So now nowhere in this map actually contains an object equivalent to this husky object with only 1 lily. So yeah, since this line is executed, all the objects haven't changed to lily, so no objects equivalent can be found in this hash map, so it would return null. And the third question is what happens when we get the new the updated version of object A. So to get an object in a hash map, we first compute the hash code, which would be 10, mod 4 would be 2, and so we would look in the second bucket. So looking in bucket 2, we find that this object right here is the one that we want. So we return the map's value of 3, and that's how it returns. That's how this method call returns 3 in the end. And that's it. Thank you for listening.